Sorry about that. I had to delete some things off my phone because my phone ran out of storage. So part 2, where we left off, I was saying that as a shortcut, you could just square the 0.999 and not worry about the c's because they cancel out. That's why the c squared is there. When we do that, we get 22.4 for gamma. So gamma is a factor that represents how much more the speed is than this, or sorry, how much less the speed is than the speed of light. Okay, so now we have that number to plug into our kinetic energy formula. So that would be K equals gamma minus 1 mc squared. We found gamma, it was 22.4. There's no units attached to gamma. And then mc squared is it's the same as the rest energy. So we can just plug in what we found before for the rest energy because that's equal to mc squared. Okay, so this has no units, this has joules, so our answer will be also joules. And we get 1.75 times 10 to the negative 12 joules. Okay, so zooming out, we found the rest energy and the kinetic energy. If you were asked for the total energy of this electron, it would be these two added up. All right, so let's talk about processes that actually convert mass into energy. So when we have a high energy electron colliding with an atom in a target material, it can knock out another electron. So here's an image of that. We've got a high energy electron and it's going to hit this target electron. What you'd expect to happen is to see it knock out that electron, and so 2 electrons would come out, the one that came in and the ejected target electron. Instead, we actually see 4 particles, and this can be detected in a lab. So 3 electrons are going to come out actually instead of just 2, and something called a positron. A positron is a particle with the same mass as an electron, but with a positive charge. So what actually happens, instead of 2 coming out once it hits 1, 4 come out. And you can imagine these each have a mass, and so technically it looks like we created mass, right? Because we had 2 electrons worth of mass to start, and now we have 4. So the electron and positron, the extras, appeared to have been created out of nothing. Instead, they were actually created out of energy. So not only can particles be created out of energy in processes just like this, particles can return to energy. So we can convert energy into mass or mass into energy. So the opposite process would be when we have a particle and an antiparticle. So for example, an electron and a positron. And when they collide, when they meet each other, they annihilate, they go away, and photons are given off. And photons have energy. So their masses go away, and it is converted into the energy of a photon. So mass and energy is equivalent. It's given by E equals mc squared. If we have mass transformed into energy, we'll get this much energy. If we have energy transformed into mass, we'll get this much mass. Let's see. All right. We're going to do 2 more practice problems, and then there is 2 homework problems, and then I think I put the workbook in there too. I hope I gave that too. But if it's not in the packet, don't worry about it. Okay, 35. What are the kinetic energy, rest energy, and total energy of a 1 gram particle with that speed? So we have to find the rest and kinetic individually and then add them up to find the total. So the rest energy is going to be E sub 0 equals mc squared. So the mass is 0.001 kilograms. 1, 2, 3, yeah. And speed of light is 3 times 10 to the 8th. So that's going to get multiplied. Let me grab a calculator. And we get 9 times 10 to the 13 joules. So that's our rest energy. It's quite big because we have a 1 gram particle. The mass is fairly large compared to small things, right? Okay, so that's the rest energy. The kinetic energy, it's moving near the speed of light, so we have to use our special formula. First thing we have to do is find gamma. Gamma is 1 over square root 1 minus v squared over c squared. So it's going to be 1 over square root 1 minus 0.8 squared. I'm not going to worry about the c's. I know they cancel out. Okay, this gets us rounding to 1 sig fig, we get 2 joules. So we've got the rest, we've got, oh, sorry, we're not done. Okay, it's just 2, gamma's 2. We have to find the energy. So kinetic energy formula is gamma minus 1 mc squared. So gamma is 2. mc squared is the rest energy. This is 1 because 2 minus 1 is 1. So it looks like in this case that the kinetic energy and the rest energy are actually the same. Okay, so then the total energy is rest plus kinetic. So these two added up. Which is, if we double that, rounding to 1 sig fig, we get 2 times 10 to the 14 joules. So that's the total energy of a 1 gram particle moving at a really fast speed. It's pretty high. Okay, one more practice. At what speed is the particle's kinetic energy twice its rest energy? So we are given kinetic energy is twice the rest energy. Oh, there's my answer key. Cool. Kinetic energy equals 2 times the rest energy. And we want to find the speed that equals. So let's put in the formulas for these guys. We get for kinetic gamma times minus 1 times mc squared. So 1 over square root 1 minus v squared over c squared minus 1. So that's gamma minus 1 mc squared equals 2 mc squared. Okay, don't worry, some things are going to cancel. Looking at both sides of the equation, we have an mc squared factor that we can cross out. And so basically we want to find the speed that makes this true. So set all up, that would look like 1 over 1 minus v squared over c squared minus 1 equals 2. We're solving this equation for v. So we would add 1 to both sides. And then we're going to do our swappy. right? These guys get swapped. So we've got 1/3 equals square root 1 minus v squared over c squared. Okay, we don't have that compound fraction anymore. We are still solving for v, so we need to get rid of the square root by squaring both sides. Okay, got some room over here. Once we square both sides, 1/3 squared is 1/9. And so we've got 1/9 equals 1 minus v squared over c squared. We can do our swappy with these guys. They can change places. So then we get v squared over c squared equals 1 minus 1/9, which is 8/9. Okay, so 8/9 is v squared over c squared. We want to find v over c. So we're going to square root both sides. I'm just going to change it to a decimal at this point. I was trying to hold on to our fraction, but whatever. So then we get v equals 0.94 c. Just to really spell that out, it would be v over c is 0.94, and then we multiply both sides by c to get that. Okay, like I said, there's 2 homework questions, and I think I put the workbook in there. If it's not in your packet, don't worry about doing it. So work on those practice problems, and we'll check back in when you come back.